Hello and welcome to another video. In this video we're going to be working on remove k digits, and in the problem you're given a string num representing a non-negative integer num and an integer k. Return the smallest positive integer after removing k digits from num. So in this first example you remove 432, so you get 1219. In the second example you remove the 1, so you get 0, 200, and there is no leading 0, so you just want 200. And in the third one you can just get rid of everything. And so there's a 10 to the 5th constraint, and there's no leading zeros. So the main thing about this problem is like, what numbers do we want to remove? And the main thing usually for minimizing a number is digits at the front are worth more than the back. And what I mean by that is like when you do digit comparison, let's say I have a 9 here, or not even a 9, let's say I have a 2. And then I have like 9, 9, 9, 9, whatever, the same length. And let's say I have a 1 here. Oh, actually, no, instead of a 1, let's say I have a 3 here. And now these are all 1s. Well, this number is bigger because the leading number is bigger, right? So if the first number is bigger than the second number for one of these, like the first digit, the most significant digit is bigger, then everything else doesn't matter, right? Like this is irrelevant. So the priority should be to minimize the most significant digit. So obviously you always want to remove numbers, because like if you can remove numbers, like if I can remove 3 numbers, I'm always going to want to remove, because every time I remove a number, I'm basically like dividing by 10 roughly, right? So I'm always going to want it to remove, but I want to make sure that like, given that I know I want to remove stuff, I want to prioritize making my most significant digit the biggest one that I can. And so let's say we have this 1432219. So how should I prioritize doing this? And I have 3 deletions. Well, what I can do is like, if I delete, like I'm going to delete 3 numbers regardless, but like if I delete this 1, then my first digit will be a 4, and it's better to have a 1 than a 4, right? So I want to have the first digit as small as possible, and then I want to have the second digit as small as possible, and so on. And I want to prioritize them in that order, right? The first digit needs to be as small as possible. If there's a tie, then make the second digit as small as possible, and so on. And so the way to do this is pretty straightforward. So what you're going to want to do is we can just put on digits and use a stack. And then whenever we get a digit that's bigger than one we have already, or actually, sorry, smaller than one we have already, then we will just pop off the one we have because there's one that's better. And we want to make sure we only can do 3 pops. So let's take a look at what this is going to look like, and then we'll look at a couple different examples. So like in the beginning, we're going to put on a 1 here, right? Because there's nothing on the stack. Then we're going to be on the 4, and we're going to say, okay, so we can either keep the 1 and put on the 4, or we can get rid of the 1 and put on the 4. Well, if we get rid of the 1 and put on the 4, our answer is always going to be like the same amount of digits. It might be a little bit less if there's zeros, but that part doesn't matter. So we know that like we want to keep the 1 and put on the 4, because if we get rid of the 1, then our first digit will be a 4, and we're better off having a 1. So we'll put on a 4 here, then we'll come over here, and we say, okay, we have a 3. We can either get rid of the 4, and now our second digit will be a 3, or we can keep the 4. Well, it's better to have a 3 as a second digit than a 4, right? Because that'll be smaller. So we're going to pop the 4. And you might want to pop multiple times. So we pop the 4. Now we compare the 3 to the 1. Is it better to have our first digit be a 1 or a 3? It's better to have a 1. So now we're done popping. And now we put on a 3. And now we have k equals 2, right? We did 1 pop, so we got rid of 1 digit. Then we come over here, so we have a 2. So we say, okay, do we want our second digit to be a 3 or a 2? Well, a 2 is going to make it smaller, so we can pop the 3. Then do we want our first digit to be a 1 or a 2? Well, a 1's better, so we're going to keep that. So this is now a 2, and now we have 1 more pop left. So now we have a 2, and so here, we can pop a 2 and put on a 2, but that doesn't really matter. So for a tie, like it's not going to make it any better. So essentially, you want your digits to be all in increasing or equal order, and that's the idea for your answer. So we have a 2 here, then we get to a 1. And now we say, well, our third digit can be a 2 or a 1. What's better? Well, obviously 1's better. So we're going to pop the 2 and put on the 1. So we're prioritizing leading digits. And then now we have no more pops left. So we just put on, now we have to put on whatever is left. So just the 9. Yeah. So we get 1219, which is just what we return. So if we go back to this example, and same exact thing, but now let's say our number is a little bit different. So instead of 143, maybe let's make it like 431. Let's go through this one, and then let's go through a couple more like edge cases. So for 431, we would put on the 4, and then we'd say, okay, we're at a 3 now. Is it better to have our first digit be a 3 or a 4? Well, 3 is smaller, so we're going to pop. So essentially, while our last digit is bigger than what we're putting on, we'll just pop. So then we put on a 3. We have 2 more pops that we can still use. And then now we have a 1. So is it better to have a 1 or a 3 as the first digit? Well, it's better to have a 1, so we'll pop. So put on 1. Now we have 1 pop left. And then for the 2, we're not going to pop because a 1's better. Then for the 2, we're not going to pop. Now we have a 1 again, so now we are going to pop our last 2, because that's all the ones we can pop, and then we'll get this. So you can see it changed a little bit. We got the same answer, but you can see like kind of how it works. Now let's talk about a couple edge cases. So let's say our number is not this, but let's just say it's something like 1, 2, 3, 4, 5, 6. So what's going to happen here is, and let's say k is 3 again. So what's going to happen here is we're never going to pop, right? We're going to put on a 1, then we're going to go to the 2 and be like, well, like the 1 is better at the front, so we're never going to pop here, never going to pop, never going to pop, never going to pop. Because every number we get is like, if we got rid of something, like if this was 1, 2, 4, 5, 6 instead of 1, 2, 3, 4, it would be worse. So this is like the best. Now we still have 3 pops. So we didn't manage to like make anything smaller, but we still have 3 pops. So basically whenever we have pops left over and our numbers at the end are increasing, right? Like our numbers at the end will always be increasing, assuming we have pops left. Then it's pretty easy. We just pop off the last 3 because that's going to give us the best thing. So if we have 3 pops left, we just pop these off. So whatever pops we have left after getting our stack, like our stack will always be in increasing order at the end, we just pop off the last ones because those are going to be the best. Those are going to be like the biggest numbers and the worst ones to keep. And it's never going to be better to like, you know, get rid of this 4 and make it like 5, 6 instead or something. It's always better to just pop from the end if we have something left. So that's one case. Another case is like this case right here. Like let's look at example 2. So let's look at example 2 and then like one more case, I guess. So for example 2, when we have 1, 0, 2, 0, 0, so we're going to put on a 1. And then we're on the 0 and we have 1 pop total. So we're on the 0. Now, is it better to have our first digit be a 0 or a 1? Well, 0 is smaller, so we're going to pop the 1, put on the 0. Now we have no pops left, so our number is like this. So we want to return 200, not 0, 200. And this is going to be a string, right? Because this can be like 10 and 5 digits. So you can't really like convert this to a number and convert it back into a string. It's going to be a string. So you can handle this as you build a stack, and that's actually what I'm going to do. So I'm just going to make sure that like if I have an empty stack and a 0, I'm just never going to put this on. So what's going to happen here is I'm going to pop the 1, and then when I try to put on the 0, I'm going to say, okay, I have an empty stack and a 0. That's just going to be meaningless, so I'm never going to put this on. Then I'll put on the 200. Then we can return. The last case is, so, and I think this can happen. Yeah, it can definitely happen. So let's say k is like 10, and our number is like something easy, like, or not even 10. Let's say k is like 3. And our number is like 1 or something like this, right? So basically here, you're just going to have like an empty stack. And so you'll have some cases where you have an empty stack at the end, and k is like bigger than the length of you might not have an empty stack, but you'll have some stack, and the k you have left is actually just bigger. In that case, we can just return 0. Or k is equal to our stack. Like for this case, we're going to have a 1, and then when we try to put on the 0, we're going to pop the 1. And so we'll have this, or we'll either have this or the empty stack. So in all these cases, whenever we have an empty stack or some kind of stack where k is bigger, we'll just check if k is bigger than our stack, like whatever we have left, we can just return 0. And so that's pretty much going to be all the cases. But yeah, there's one more that I wanted to go over briefly as to why you'd want to use a stack. So it's something like this: 1, 2, 3, 4, 5, 6, and then a 0, and k is 6. So in this case, this is why you'd want to use a stack. You're not just going to pop one time, because what's going to happen here is you're actually going to put on like 1, 2, 3, 4, 5, 6, and then you get to the 0. And now because 0 is actually less than all of these, you're actually going to pop off all of these. And so that's why you want to use a stack, because you have to, like, once you get to one number, you might pop off like a bunch of things. And so your thing will be like this, or just an empty, or whatever you want. But this should return 0. So that's kind of the intuition to doing the stack. Like, you might have tried something else, and there's literally a test case just like this, and then you're like, okay, I need to pop off multiple things. And yeah, that's basically it. So now we can code this up in Java. So we're going to use a string builder to simulate our stack. So we're going to use string builder, and basically we are going to just loop through all of the characters in the number. We can't convert it to a number, and we're going to handle the case where we have leading zeros just by never putting them in the stack. So if the stack is empty and we have a 0, we just won't put it in. You could also handle it a different way. You could put it in and then just like move your start index up at the end, but we're just going to take care of it as we build it. So we're going to loop through our number, or string. And so the condition for popping off the stack is like we have to have pops left, right? So k has to be greater than 0. And our string builder can't be empty, or our stack can't be empty. So builder is empty. So this has to be false. And our last character in our string builder has to be greater than the character we're putting in. So and builder, let's see what method we need. I think it's this one, character at, and the index is going to be builder. This one is greater than the current character we're on. So if this is true, then we can just pop. And let's see what thing we need here. I don't think they have like a pop. Yeah, maybe they do, but yeah. So we're gonna use delete character at. Yeah. Okay, so we're going to delete character at this index. So our last character in the string builder, we're just going to pop. And we're going to do this as much as we can. Maybe I like renamed it something wrong, or we'll see. Yeah, so we're going to do this as much as we can. We're going to pop as much as we can until like one of these is not true, right? So while we can, we're going to keep popping. Then, oh yeah, I forgot one thing. This will infinite loop, so we need to decrement k every time we pop. And then we just need to add our number. And we're going to handle it here, right? So we don't want the leading 0, so we can handle it here. So we can say if builder is empty. So if it is empty, let's see. Actually, if it's not empty. So if it's not empty, or... So basically, the only case we don't want to add a number is if it is empty and it's a 0. So if it's not empty, or it's not a 0, it's fine. But if it is empty and it's 0, then we don't want to do it. So we can say num character at I does not equal 0. If both of these are true, we don't want to add. And everything else we do want to add. So this will take care of not adding leading zeros. Append, yeah, append, and this is just going to be this. Okay, so not sure. Oh yeah, because it's a string in Java. Okay. So then what we want to do is finally we want to check, does our string, like, is our stack greater than k? So we can return. So if k is greater than or equal to our builder length, our stack length, then we can just return the 0, because like we're just going to pop off every number. So if this is true, we're going to return 0, because we're going to pop off every number. We'll just have a 0. Otherwise, we can just do a substring here. And so like I said, let's say we do have pops left over, because our stack will be increasing, you're just going to want to pop off the last k numbers from the stack. So if it's like 1, 2, 3, 4, 5, 6, and k is 3, you're basically just going to want to return the first 3, pop off the last 3. And so we can just do a substring here. So I think builder has a substring, so we're going to start at index 0, and then we're going to want to end at, so like the whole thing, if you want the whole substring, like the whole entire thing, it would be this. But we want this minus the last k characters, so it should be this, I believe. So let's try that. Okay, cool. Yeah, so yeah, definitely a lot more wordy than in Python. Python's pretty fast. Oh yeah, and the other thing I wanted to mention, so I'm just gonna post code for Java and Python and TypeScript solutions, in GitHub instead of like the Google Drive thing that I've been doing, so you can look at like different solutions and stuff. And if you want to add your own, you can do that as well. But yeah, so let's go through the time here. So essentially, what did we do? So we went through our entire string, which is ov(n). We added to the stack, deleted from the stack. That's all ov(n) using a stack's ov(n). Then like getting a substring is also ov(n) because we only have to do that one time. So this is basically just ov(n). And then space. So we use a stack, so that's ov(n) as well. Yeah, so reasonably simple problem. Just the main concept that comes up in a lot of these problems, how to minimize the number. Just remember that the leading digits matter more than everything else. So if you can make the leading digit smaller than for one number than the other, then the other digits are irrelevant. So the only thing that contributes to, how is a number bigger than another, it's just the first difference in like the leftmost digit. So if the leftmost digit is the same, then you compare the second digit and so on. And whenever there's a difference, that's going to be which one's bigger or smaller. The rest of the numbers don't matter after that. So that's what you want to prioritize. Yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.